Magicoder. Source code is all you need. We introduce Magicoder, a series of fully open source code, weights and data, large language models, LLMs, for code that significantly closes the gap with top code models while having no more than 7 billion parameters. Magicoder models are trained on 75,000 synthetic instruction data using OSS Instruct, a novel approach to enlightening LLMs with open-source code snippets to generate high-quality instruction data for code. Our main motivation is to mitigate the inherent bias of the synthetic data generated by LLMs by empowering them with a wealth of open-source references for the production of more diverse, realistic, and controllable data. The orthogonality of OSS Instruct and other data generation methods like Evol Instruct further enables us to build an enhanced Magicoders. Both Magicoder and Magicoders substantially outperform state-of-the-art code models with similar or even larger sizes on a wide range of coding benchmarks, including Python text-to-code generation, multilingual coding, and data science program completion. Notably, Magicoder's CL7B, based on Codalama, even surpasses the prominent ChatGPT on Human Evil, plus 66.5 versus 65.9 in pass at 1. Overall, OSS Instruct opens a new direction for low bias and high-quality instruction tuning using abundant open-source references. VMC. Video motion customization using temporal attention adaption for text-to-video diffusion models. Text-to-video diffusion models have advanced video generation significantly. However, customizing these models to generate videos with tailored motions presents a substantial challenge. In specific, they encounter hurdles in A, accurately reproducing motion from a target video, and B, creating diverse visual variations. For example, straightforward extensions of static image customization methods to video often lead to intricate entanglements of appearance and motion data. To tackle this, here we present the Video Motion Customization (VMC) framework, a novel one-shot tuning approach crafted to adapt temporal attention layers within video diffusion models. Our approach introduces a novel motion distillation objective using residual vectors between consecutive frames as a motion reference. The diffusion process then preserves low-frequency motion trajectories while mitigating high-frequency motion unrelated noise in image space. We validate our method against state-of-the-art video generative models across diverse real-world motions and contexts. Our codes, data, and the project demo can be found at the project's website. The unlocking spell on base LLMs, rethinking alignment via in-context learning. The alignment tuning process of large language models typically involves instruction learning through supervised fine-tuning and preference tuning via reinforcement learning from human feedback. A recent study, Lima, shows that using merely 1K examples for supervised fine-tuning can achieve significant alignment performance as well, suggesting that the effect of alignment tuning might be superficial. This raises questions about how exactly the alignment tuning transforms a base language model. We analyze the effect of alignment tuning by examining the token distribution shift between base language models and their aligned counterpart. Our findings reveal that base language models and their alignment-tuned versions perform nearly identically in decoding on the majority of token positions. Most distribution shifts occur with stylistic tokens. These direct evidence strongly supports the superficial alignment hypothesis suggested by Lima. Based on these findings, we rethink the alignment of language models by posing the research question: how effectively can we align base language models without supervised fine-tuning or reinforcement learning from human feedback? To address this, we introduce a simple, tuning-free alignment method called Uriel. Uriel achieves effective alignment purely through in-context learning with base language models, requiring as few as 3 constant stylistic examples and a system prompt. We conduct a fine-grained and interpretable evaluation on a diverse set of examples, named Just Eval Instruct. Results demonstrate that base language models with Uriel can match or even surpass the performance of language models aligned with supervised fine-tuning or supervised fine-tuning followed by reinforcement learning from human feedback. We show that the gap between tuning-free and tuning-based alignment methods can be significantly reduced through strategic prompting and in-context learning. Our findings on the superficial nature of alignment tuning and results with URL suggest that deeper analysis and theoretical understanding of alignment is crucial to future language model research. Segment and caption anything. We propose a method to efficiently equip the Segment Anything model, SAM, with the ability to generate regional captions. SAM presents strong generalizability to segment anything, while is short for semantic understanding. By introducing a lightweight query-based feature mixer, we align the region-specific features with the embedding space of language models for later caption generation. As the number of trainable parameters is small, typically in the order of tens of millions, it costs less computation, less memory usage, and less communication bandwidth, resulting in both fast and scalable training. To address the scarcity problem of regional caption data, we propose to first pre-train our model on objection detection and segmentation tasks. We call this step weak supervision pre-training, since the pre-training data only contains category names instead of full sentence descriptions. The weak supervision pre-training allows us to leverage many publicly available object detection and segmentation datasets. We conduct extensive experiments to demonstrate the superiority of our method and validate each design choice. This work serves as a stepping stone towards scaling up regional captioning data and sheds light on exploring efficient ways to augment SAM with regional semantics. The project page, along with the associated code, can be accessed via the project's website. VideoSwap, customized video subject, swapping with interactive semantic point correspondence. Current diffusion-based video editing primarily focuses on structure-preserved editing by utilizing various dense correspondences to ensure temporal consistency and motion alignment. However, these approaches are often ineffective when the target edit involves a shape change. To embark on video editing with shape change, we explore customized video subject swapping in this work, where we aim to replace the main subject in a source video with a target subject having a distinct identity and potentially different shape. In contrast to previous methods that rely on dense correspondences, we introduce the VideoSwap framework that exploits semantic point correspondences, inspired by our observation that only a small number of semantic points are necessary to align the subject's motion trajectory and modify its shape. We also introduce various user point interactions, such as removing points and dragging points, to address various semantic point correspondence. Extensive experiments demonstrate state-of-the-art video subject swapping results across a variety of real-world videos. Segment: any 3D Gaussians. Interactive 3D segmentation in Radiance fields is an appealing task since its importance in 3D scene understanding and manipulation. However, existing methods face challenges in either achieving fine-grained multigranularity segmentation or contending with substantial computational overhead, inhibiting real-time interaction. In this paper, we introduce Segment Any 3D Gaussians, SAGA, a novel 3D interactive segmentation approach that seamlessly blends a 2D segmentation foundation model with 3D Gaussian splatting, 3DGS, a recent breakthrough of Radiance fields. SAGA efficiently embeds multigranularity 2D segmentation results generated by the segmentation foundation model into 3D Gaussian point features through well-designed contrastive training. Evaluation on existing benchmarks demonstrates that SAGA can achieve competitive performance with state-of-the-art methods. Moreover, SAGA achieves multigranularity segmentation and accommodates various prompts, including points, scribbles, and 2D masks. Notably, SAGA can finish the 3D segmentation within milliseconds, achieving nearly 1000x acceleration compared to previous state-of-the-art SOTA. The project page is at project's website. Object recognition as next token, prediction. We present an approach to pose object recognition as next token prediction. The idea is to apply a language decoder that auto-regressively predicts the text tokens from image embeddings to form labels. To ground this prediction process in auto-regression, we customize a non-causal attention mask for the decoder, incorporating two key features: modeling tokens from different labels to be independent, and treating image tokens as a prefix. This masking mechanism inspires an efficient method, one-shot sampling, to simultaneously sample tokens of multiple labels in parallel and rank generated labels by their probabilities during inference. To further enhance the efficiency, we propose a simple strategy to construct a compact decoder by simply discarding the intermediate blocks of a pre-trained language model. This approach yields a decoder that matches the full model's performance while being notably more efficient. The code is available at project's website. GIVT, Generative Infinite Vocabulary Transformers. We introduce Generative Infinite Vocabulary Transformers, GIVT, which generate vector sequences with real-valued entries instead of discrete tokens from a finite vocabulary. To this end, we propose two surprisingly simple modifications to decoder-only transformers. 1. At the input, we replace the finite vocabulary lookup table with a linear projection of the input vectors. And 2. At the output, we replace the logitis prediction, usually mapped to a categorical distribution, with the parameters of a multivariate Gaussian mixture model. Inspired by the image generation paradigm of VQ-GAN and MaskGit, where transformers are used to model the discrete latent sequences of a VQ-VAE, we use GIVT to model the unquantized real-valued latent sequences of a VAE. When applying GIVT to class-conditional image generation with iterative masked modeling, we show competitive results with MaskGit, while our approach outperforms both VQ-GAN and MaskGit when using it for causal modeling. Finally, we obtain competitive results outside of image generation when applying our approach to panoptic segmentation and depth estimation with a VAE-based variant of the UVIM framework, RLHF-V, towards trustworthy MLLMs via behavior alignment from fine-grained correctional human feedback. Multimodal large language models, MLLMs, have recently demonstrated impressive capabilities in multimodal understanding, reasoning, and interaction. However, existing MLLMs prevalently suffer from serious hallucination problems, generating text that is not factually grounded in associated images. The problem makes existing MLLMs untrustworthy and thus impractical in real-world, especially high-stakes applications. To address the challenge, we present RLHF-V, which enhances MLM trustworthiness via behavior alignment from fine-grained correctional human feedback. Specifically, RLHF-V collects human preference in the form of segment-level corrections on hallucinations and performs dense direct preference optimization over the human feedback. Comprehensive experiments on 5 benchmarks in both automatic and human evaluation show that RLHF-V can enable substantially more trustworthy MLLM behaviors with promising data and computation efficiency. Remarkably, using 14K annotated data samples, RLHF-V significantly reduces the hallucination rate of the base MLLM by 34.8%, outperforming the concurrent ELAVA RLHF trained on 10K annotated data. The final model achieves state-of-the-art performance in trustworthiness among open-source MLLMs and shows better robustness than GPT-4V in preventing hallucinations aroused from overgeneralization. We open-source our code, model, and data at the project's website. DeepCache, accelerating diffusion models for free. Diffusion models have recently gained unprecedented attention in the field of image synthesis due to their remarkable generative capabilities. Notwithstanding their prowess, these models often incur substantial computational costs, primarily attributed to the sequential denoising process and cumbersome model size. Traditional methods for compressing diffusion models typically involve extensive retraining, presenting cost and feasibility challenges. In this paper, we introduce DeepCache, a novel training-free paradigm that accelerates diffusion models from the perspective of model architecture. DeepCache capitalizes on the inherent temporal redundancy observed in the sequential denoising steps of diffusion models, which caches and retrieves features across adjacent denoising stages, thereby curtailing redundant computations. Utilizing the property of the U-net, we reuse the high-level features while updating the low-level features in a very cheap way. This innovative strategy, in turn, enables a speed-up factor of 2.3 times for Stable Diffusion version 1.5, with only a 0.05 decline in clip score, and 4.1 times for LDM4G, with a slight decrease of 0.22 in FID, fresh at inception distance, on ImageNet. Our experiments also demonstrate DeepCache's superiority over existing pruning and distillation methods that necessitate retraining, and its compatibility with current sampling techniques. Furthermore, we find that under the same throughput, DeepCache effectively achieves comparable or even marginally improved results with DDIM or PLMS, parallel large memory systems. The code is available at the project's website. Fast view synthesis of casual videos. Novel view synthesis from an in-the-wild video is difficult due to challenges like scene dynamics and lack of parallax. While existing methods have shown promising results with implicit neural radiance fields, they are slow to train and render. This paper revisits explicit video representations to synthesize high-quality novel views from a monocular video efficiently. We treat static and dynamic video content separately. Specifically, we build a global static scene model using an extended plane-based scene representation to synthesize temporally coherent novel video. Our plane-based scene representation is augmented with spherical harmonics and displacement maps to capture view-dependent effects and model non-planar complex surface geometry. We opt to represent the dynamic content as per-frame point clouds for efficiency. While such representations are inconsistency-prone, minor temporal inconsistencies are perceptually masked due to motion. We develop a method to quickly estimate such a hybrid video representation and render novel views in real time. Our experiments show that our method can render high-quality novel views from an in-the-wild video with comparable quality to state-of-the-art methods, while being 100x faster in training and enabling real-time rendering. VideoRF, rendering dynamic radiance fields as 2D feature video streams. Neural radiance fields, NeRFs, excel in photorealistically rendering static scenes. However, rendering dynamic long-duration radiance fields on ubiquitous devices remains challenging due to data storage and computational constraints. In this paper, we introduce VideoRF, the first approach to enable real-time streaming and rendering of dynamic radiance fields on mobile platforms. At the core is a serialized 2D feature image stream representing the 4D radiance field all-in-one. We introduce a tailored training scheme directly applied to this 2D domain to impose the temporal and spatial redundancy of the feature image stream. By leveraging the redundancy, we show that the feature image stream can be efficiently compressed by 2D video codecs, which allows us to exploit video hardware accelerators to achieve real-time decoding. On the other hand, based on the feature image stream, we propose a novel rendering pipeline for VideoRF, which has specialized space mappings to query radiance properties efficiently. Paired with a deferred shading model, VideoRF has the capability of real-time rendering on mobile devices thanks to its efficiency. We have developed a real-time interactive player that enables online streaming and rendering of dynamic scenes, offering a seamless and immersive free viewpoint experience across a range of devices, from desktops to mobile phones. Generative Powers of Ten. We present a method that uses a text-to-image model to generate consistent content across multiple image scales, enabling extreme semantic zooms into a scene, for example, ranging from a wide-angle landscape view of a forest to a macro shot of an insect sitting on one of the tree branches. We achieve this through a joint multi-scale diffusion sampling approach that encourages consistency across different scales while preserving the integrity of each individual sampling process. Since each generated scale is guided by a different text prompt, our method enables deeper levels of zoom than traditional super-resolution methods that may struggle to create new contextual structure at vastly different scales. We compare our method qualitatively with alternative techniques in image super-resolution and outpainting, and show that our method is most effective at generating consistent multi-scale content. Rejuvenating image-GPT as strong visual representation learners. This paper enhances image-GPT, IGPT, one of the pioneering works that introduce auto-regressive pre-training to predict next pixels for visual representation learning. Two simple yet essential changes are made. First, we shift the prediction target from raw pixels to semantic tokens, enabling a higher-level understanding of visual content. Second, we supplement the auto-regressive modeling by instructing the model to predict not only the next tokens, but also the visible tokens. This pipeline is particularly effective when semantic tokens are encoded by discriminatively trained models, such as CLIP. We introduce this novel approach as DIGPT. Extensive experiments showcase that DIGPT excels as a strong learner of visual representations. A notable achievement of DIGPT is its compelling performance on the ImageNet 1K dataset. By training on publicly available datasets, DIGPT achieves 89.5% top-1 accuracy with a vanilla VideoRF large model. This model also shows strong generalization on the downstream task and robustness on out-of-distribution samples. Code is available at the project's website. Using large language models to accelerate communication for users with severe motor impairments. Finding ways to accelerate text input for individuals with profound motor impairments has been a long-standing area of research. Closing the speed gap for augmentative and alternative communication, AAC devices, such as eye-tracking keyboards, is important for improving the quality of life for such individuals. Recent advances in neural networks of natural language pose new opportunities for rethinking strategies and user interfaces for enhanced text entry for AAC users. In this paper, we present Speak Faster, consisting of large language models, LLMs, and a co-designed user interface for text entry in a highly abbreviated form, allowing saving 57% more motor actions than traditional predictive keyboards in offline simulation. A pilot study with 19 non-AAC participants typing on a mobile device by hand demonstrated gains in motor savings in line with the offline simulation, while introducing relatively small effects on overall typing speed. Lab and field testing on 2 eye-gaze typing users with amyotrophic lateral sclerosis, ALS, demonstrated text entry rates 60% faster than traditional baselines, due to significant saving of expensive keystrokes achieved through phrase and word predictions from context-aware LLMs. These findings provide a strong foundation for further exploration of substantially accelerated text communication for motor-impaired users and demonstrate a direction for applying LLMs to text-based user interfaces. DiffiT, Diffusion Vision Transformers for Image Generation. Diffusion models with their powerful expressivity and high sample quality have enabled many new applications and use cases in various domains. For sample generation, these models rely on a denoising neural network that generates images by iterative denoising. Yet the role of denoising network architecture is not well studied, with most efforts relying on convolutional residual U-nets. In this paper, we studied the effectiveness of vision transformers in diffusion-based generative learning. Specifically, we propose a new model, denoted as Diffusion Vision Transformers, DiffiT, which consists of a hybrid hierarchical architecture with a U-shaped encoder and decoder. We introduce a novel time-dependent self-attention module that allows attention layers to adapt their behavior at different stages of the denoising process in an efficient manner. We also introduce latent DiffiT, which consists of a transformer model with the proposed self-attention layers for high-resolution image generation. Our results show that DiffiT is surprisingly effective in generating high-fidelity images, and it achieves state-of-the-art SOTA benchmarks on a variety of class-conditional and unconditional synthesis tasks. In the latent space, DiffiT achieves a new SOTA FID score of 1.73 on ImageNet 256 dataset. Repository Project's website. Style-aligned image generation via shared attention. Large-scale text-to-image T2I models have rapidly gained prominence across creative fields, generating visually compelling outputs from textual prompts. However, controlling these models to ensure consistent style remains challenging, with existing methods necessitating fine-tuning and manual intervention to disentangle content and style. In this paper, we introduce style-aligned, a novel technique designed to establish style alignment among a series of generated images. By employing minimal attention sharing during the diffusion process, our method maintains style consistency across images within T2I models. This approach allows for the creation of style-consistent images using a reference style through a straightforward inversion operation. Our method's evaluation across diverse styles and text prompts demonstrates high-quality synthesis and fidelity, underscoring its efficacy in achieving consistent style across various inputs. Generative rendering. Controllable 4D guided video generation with 2D diffusion models. Traditional three-dimensional 3D content creation tools enable users to bring their imagination to life by providing direct control over a scene's geometry, appearance, motion, and camera path. However, creating computer-generated videos is a laborious manual process. Recent advances in text-to-video diffusion models have offered the potential for automation. Despite their promise, these video diffusion models are challenging to control, limiting user creativity rather than enhancing it. To address this challenge, we propose a new approach that combines the controllability of dynamic 3D meshes with the expressivity and editability of emerging diffusion models. Our approach takes an animated, low-fidelity rendered mesh as input and incorporates ground truth correspondence information from the dynamic mesh into different stages of a pre-trained text-to-image generation model. This results in high-quality and temporally consistent frames. We demonstrate the effectiveness of our approach using various examples, where motion can be achieved through animating rigged assets or adjusting the camera path. Customize your NeRF adaptive source, driven 3D scene editing via local global iterative training. In this paper, we target the adaptive source-driven 3D scene editing task by proposing a custom NeRF model that unifies a text description or a reference image as the editing prompt. However, obtaining desired editing results conformed with the editing prompt is non-trivial, since there exist two significant challenges, including accurate editing of only foreground regions and multi-view consistency given a single-view reference image. To tackle the first challenge, we propose a local global iterative editing (LGIE) training scheme that alternates between foreground region editing and full image editing, aimed at foreground-only manipulation while preserving the background. For the second challenge, we also design a class-guided regularization that exploits class priors within the generation model to alleviate the inconsistency problem among different views in image-driven editing. Extensive experiments show that our custom NeRF produces precise editing results under various real scenes for both text and image-driven settings. SANeRF-HQ, segment anything for NeRF in high quality. Recently, the Segment Anything model, SAM, has showcased remarkable capabilities of zero-shot segmentation, while NeRF, neural radiance fields, has gained popularity as a method for various 3D problems beyond novel view synthesis. Though there exist initial attempts to incorporate these two methods into 3D segmentation, they face the challenge of accurately and consistently segmenting objects in complex scenarios. In this paper, we introduce the Segment Anything for NeRF in high quality, SANeRF-HQ, to achieve high-quality 3D segmentation of any object in a given scene. SANeRF-HQ utilizes SAM for open-world object segmentation, guided by user-supplied prompts, while leveraging NeRF to aggregate information from different viewpoints. To overcome the aforementioned challenges, we employ density field and RGB similarity to enhance the accuracy of segmentation boundary during the aggregation. Emphasizing on segmentation accuracy, we evaluate our method quantitatively on multiple NeRF datasets where high-quality ground truths are available or manually annotated. SANeRF-HQ shows a significant quality improvement over previous state-of-the-art methods in NeRF object segmentation, provides higher flexibility for object localization, and enables more consistent object segmentation across multiple views. Additional information can be found at the project's website. GPS-Gaussian, Generalizable pixel-wise 3D Gaussian splatting for real-time human novel view synthesis. We present a new approach termed GPS-Gaussian for synthesizing novel views of a character in a real-time manner. The proposed method enables 2K resolution rendering under a sparse view camera setting. Unlike the original Gaussian splatting or neural implicit rendering methods that necessitate per-subject optimizations, we introduce Gaussian parameter maps defined on the source views and regress directly Gaussian splatting properties for instant novel view synthesis without any fine-tuning or optimization. To this end, we train our Gaussian parameter regression module on a large amount of human scan data, jointly with a depth estimation module to lift 2D parameter maps to 3D space. The proposed framework is fully differentiable, and experiments on several datasets demonstrate that our method outperforms state-of-the-art methods while achieving an exceeding rendering speed. NASH, learning from human feedback. Reinforcement learning from human feedback, RLHF, has emerged as the main paradigm for aligning large language models, LLMs, with human preferences. Typically, RLHF involves the initial step of learning a reward model from human feedback, often expressed as preferences between pairs of text generations produced by a pre-trained LLM. Subsequently, the LLM's policy is fine-tuned by optimizing it to maximize the reward model through a reinforcement learning algorithm. However, an inherent limitation of current reward models is their inability to fully represent the richness of human preferences and their dependency on the sampling distribution. In this study, we introduce an alternative pipeline for the fine-tuning of LLMs using pairwise human feedback. Our approach entails the initial learning of a preference model, which is conditioned on two inputs given a prompt, followed by the pursuit of a policy that consistently generates responses preferred over those generated by any competing policy, thus defining the Nash equilibrium of this preference model. We term this approach Nash learning from human feedback, NLHF. In the context of a tabular policy representation, we present a novel algorithmic solution, Nash-MD, founded on the principles of mirror descent. This algorithm produces a sequence of policies, with the last iteration converging to the regularized Nash equilibrium. Additionally, we explore parametric representations of policies and introduce gradient descent algorithms for deep learning architectures. To demonstrate the effectiveness of our approach, we present experimental results involving the fine-tuning of a LLM for a text summarization task. We believe NLHF offers a compelling avenue for preference learning and policy optimization, with the potential of advancing the field of aligning LLMs with human preferences. Text GenShap, scalable post-hoc explanations in text generation with long documents. Large language models, LLMs, have attracted huge interest in practical applications given their increasingly accurate responses and coherent reasoning abilities. Given their nature as black boxes using complex reasoning processes on their inputs, it is inevitable that the demand for scalable and faithful explanations for LLMs' generated content will continue to grow. There have been major developments in the explainability of neural network models over the past decade. Among them, post-hoc explainability methods, especially Shapley values, have proven effective for interpreting deep learning models. However, there are major challenges in scaling up Shapley values for LLMs, particularly when dealing with long input contexts containing thousands of tokens and auto-regressively generated output sequences. Furthermore, it is often unclear how to effectively utilize generated explanations to improve the performance of LLMs. In this paper, we introduce TextGenShap, an efficient post-hoc explanation method incorporating LM-specific techniques. We demonstrate that this leads to significant increases in speed compared to conventional Shapley value computations, reducing processing times from hours to minutes for token-level explanations and to just seconds for document-level explanations. In addition, we demonstrate how real-time Shapley values can be utilized in two important scenarios, providing better understanding of long document question answering by localizing important words and sentences, and improving existing document retrieval systems through enhancing the accuracy of selected passages and ultimately the final responses.